All right, and we're off and running. All right, last time on Wednesday, we did talk about, we began section 11.4, dealing with volumes of certain three-dimensional figures. And we did talk about things like, we started off with the volume of a prism and a rectangular prism. And then we looked at pretty much volumes of probably any prism that where the base could be in the form of some geometric figure. You have to find the area of the base and then multiply it by its height to get the volume. And also we did talk about the volume of a cylinder and how to get the volume of a cylinder from that formula. And also we did talk about the volume of an irregular shaped object. Usually you have to use a graduated cylinder, fill it up to a certain volume, and then drop the figure or the object in the circular cylinder to see where it rises. The difference between the original height, which is the volume, and the new height, that would be your volume of that particular irregular object. Then we talk about volumes of pyramids and cones, and those formulas as well. Okay, and this is the one that I left off. Okay, we did talk about the volume of a pyramid, which was a regular pentagonal pyramid. This one is a cone that you see here. Okay, and we want to find the volume of that cone, and we're going to round the final answer to the nearest 10th. So I'm going to draw a figure of some cone. And notice that the radius is 6 feet. Now notice that they give you what they call the slant height, which we're going to talk about sometime in a few minutes. So here, this blue, well, let me go and unshare this. Okay, so here, this blue line that I just drew here, that's what we call the slant height. Okay. Now, what we are missing in this problem is what this dotted line is. That's the vertical height of the cone. Okay, so if I draw this, in reality, you'll see that this is a triangle, a right triangle to be exact. This length is 6 feet, and this length here is actually 10 feet. We need to know what this height is going to be. That's the h. Okay, and if you recall, to find this length in a right triangle, we can use what they call the Pythagorean Theorem. Okay, and that Pythagorean Theorem is this: a squared plus b squared is equal to c squared. The c is your hypotenuse. So the square of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides in that right triangle. All right. So here, I'm gonna let this be A. That's 6 feet. So this will be 6 squared plus this length is the height. So that's gonna be h squared. That's what I'm trying to find. That's equal to c squared, where c is the hypotenuse. That's 10 feet. This will be 10 squared. Okay. And now we're going to simplify this. 6 squared is 6 times 6, that's 36. Plus the height is what we're trying to find, that's going to be squared, equals 10 squared, or 10 times 10, that's 100. So I got 36 plus h squared is equal to 100. So here I'm trying to find out what h is. I'm adding 36, so I need to subtract 36 on both sides. That will mean h squared is 64. And then to find out what h is, the opposite of squaring something will be to take the square root of that number. So I need to take the square root of 64. And the square root of 64 is 8. So the height that I was looking for here is 8. And this is 8 feet. That's the height. And now I can find the volume of this cone. And the volume of the cone is this formula. V is equal to 1/3 pi times the radius squared times the height. Okay? Because a cylinder is just pi r squared times the height for its volume. But since the cone is 1/3 the volume of the cylinder, we have to use 1/3. Okay? Now let's substitute. V is equal to 1/3 times pi. I'm going to use 3.14159 times the radius. This radius right here from the center to a point on the circle, that's 6 feet, and that's squared, times the height, we found that out to be 8. So here, I'll just write this up, 1/3 times 3.14159. And if I square the 6, that would be 36 times 8. And if I rounded that off to the nearest tenth, the approximate volume of that cylinder would be 301.6. And it's going to be in cubic feet. Remember, volume is always going to be in cubic feet. So that represents the volume of that circle. I mean, that cone. Okay. Any questions on this? Okay. All right, next we'll look at, if I can get to it. All right, next we'll look at surface area. Okay, volume deals with the space that's contained in that object. Now, when we look at surface area, we're looking at the total area of the surface of the object. Okay, not the space inside. It's going to be the face of that object, its area. Okay, so if a painter wanted to paint this classroom that I'm in right now, the only thing he will look at is just the surface area of the room. So he's just looking at is the walls are on the left, the right, front, and behind me, and nothing else, and not the spaces inside. I first will talk about a right prism and a right cylinder and their surface areas. Okay. Now here they're taking a rectangular, a right quadrilateral prism, and what they're doing here is breaking it apart and flattening it out into like a two-dimensional object like this right here. Okay, so you can see where the surface area is. Here we take the area of the two bases, the one on the top and the one on the bottom, and then we take the area of this flat surface right here. Okay, and the P comes from the perimeter of this object. Okay, we look at the perimeter, that's the distance around the entire base, the perimeter of the base, and then that's multiplied by its height. And then I'm going to jump over here to the other slide where they show you the the cylinder. Cylinder looks like a can. Now what they've done here is we have these two bases here, the top and the bottom. That's these two here. And then the face here is flattened out into a rectangle that looks like this. Now the 2 pi r comes from the distance around the entire circle, which is what we call the circumference. So here the circumference of the circle would be this 2 pi times the radius. And then you have your height. So that's 2 pi r times the height. That's going to be the area of this surface. And then the area of the bases, there are two circles. Each circle has an area of pi times the radius squared. So that's 2 pi r squared because we have two circles with an area of pi r squared. And then plus 2 times the radius times the height. Okay. And on the next slide, I'm going to try to move this up here so you can see those formulas here. For the surface area of a right prism and a right cylinder. So here, the base of a right prism has a perimeter of P units and the area of B units, and the prism has a height of H units, and the surface area is this. SA represents the surface area, 2 times the base, plus the perimeter times the height. And surface area is always going to be in square units. And also, if a right cylinder has a radius of R units and a height of H units, then surface area, of course, will be SA equal to 2 pi r squared. Those are the areas of the two bases, the top and the bottom, plus the 2 pi r times the H. Okay. So here's a rectangular hexagonal prism that has a base with the sides of the length 15 centimeters and an apothem of 13 centimeters. And the height of the prism is 20 centimeters, as indicated in this illustration. So we have a hexagonal prism. The hexagons are on the top and the bottom, and it's the flat surface here when you break it apart. In part A, they want the area of the base. Part B, the lateral surface area, and the surface area of the prism. What they're talking about the lateral surface area, that's going to be this flat surface that you see here. That's the lateral surface area that's in orange. Your bases are the hexagons on the top and the bottom. So if you start with the area of the base, that formula is 1/2 times the perimeter times the apothem. And that apothem is going to be that vertical line from the center to a side perpendicular to it. And that's 1/2 times. There are 6 sides in a hexagon. Each is 15 centimeters, so that's 6 times 15, times the apothem. They give that to you as 13 centimeters. Okay, so simplify that. 6 times 15 is 90. Half of 90 is 45. 45 times 13 will be 585 square centimeters. That's the area of the base. That's part A. Now, part B is the lateral surface area. That's going to be the perimeter of the base multiplied by the height. Okay, again, 6 times 15, that means each side is 15 centimeters long, times, and there's 6 sides, times 6, times 20, which is the height. And that would give you 1,800 square centimeters. And then part C, to find the surface area, we do 2 times the base plus the perimeter times the height. Well, the base was 585 square centimeters, so we do 2 times 585 plus P times the H, that's what we came up with in part B, 1,800. And the surface area will be 2,970 square centimeters. Okay, that would be the surface area of the regular hexagonal prism. Okay, questions on this? Okay. All right, this is similar to the one that we did on Wednesday when we were finding the volume of that pentagonal prism. Okay. So I'm going to go ahead and draw that figure on the screen, on the board. Trust me, this is not showing the scale. Goes up here, that goes down here, this comes down here, this way, and this way. And the measurement of the unit is in feet, so we're going to find the area of the base, the lateral surface area, and the surface area of the prism. Okay. Not the best drawn figure, but it will have to do here. Okay, so here, the area of the base. Now here, this is the base right here. That is what we call the, that's a pentagon. Okay. And of course here, the base is always 1/2 the perimeter times A, which is the aperture. Okay, so let's look at what we already have here. I'm going to draw that pentagon. Well, this is 10.3, and this is 15. Okay. So that apothem is given to us. That's 10.3. All right, in this case here, we need to find the perimeter of that pentagon. There are 5 sides in a pentagon, which are of equal length. So the perimeter there would be 5 times S. And the side has a length of 15, so 5 times 15 is 75. So the perimeter of that base is 75. So now to find the area of the base, this will be, we use this formula, 1/2 P times A. So this is 1/2 times the perimeter, that's 75, times the apothem, that's given to you as 10.3. So 1/2 of 75 times 10.3, I'll do this on the next line. This will give you, if you work this out, 386.25 square feet. That's the base. That's the area of the base that they were looking for. So that's part A right there. Part B, they want the lateral surface area. And I'm going to abbreviate this as LSA, for lateral surface area. And in this case, that's going to be equal to the perimeter times the height. Now, we already found out what the perimeter is. Now, they do give us the height. The height here is 18 feet. So that height is 18. So to find the lateral surface area, we multiply the perimeter, which was 75, times the height of 18. So 75 times 18 would be 1,350, and that's in square feet. Okay, keep in mind that the area is going to be in square feet. Okay, and then finally, part C is find the surface area of that prism. Okay, so to find the surface area, we have to use this formula: 2 times the base plus the perimeter times the height. So 2 times the base, we found this out to be 386.25 plus the perimeter times the height. Well, that's this right here, that lateral surface area. That's the perimeter times the height. That's the 1,350 that we came up with. So if we simplify that, just add those, do 2 times 386.25 and then add 1,350 to it, you get 2,122.5. And that will be in square feet. Okay. That's how we find the area of each base, the lateral surface area, and the surface area of that entire cylinder. Questions? Okay. Right, and here's the next example. This is problem number 37, where it says here, the diagram shows a cylinder, a right cylinder, not the best looking cylinder, but it is a right cylinder. Oh, come on, man. Okay, here we go. Apologize for that. I was trying to, okay, here we go again. Okay, I'll just leave it alone like this. All right, the diagram shows a right cylinder do the following and give the answer to the nearest tenth. And this is in feet. And I apologize for that not showing up well. Okay. This is 2 feet, the radius, and this height is 3 feet. That's the height. And here we're to find the area of each base as part A. So here we have a radius, that's going to be R, a 2, the height is 3. Well, the base is in the form of a circle. Okay, so this is a circle with a radius of 2 feet. And that is the formula for the area of a circle. Area is equal to pi times the radius squared. Okay. And pi, we're using 3.14159 times the radius, which is 2, and that's squared. And 2 squared is 4. And if you multiply that by 3.14159 to 1 decimal place, this will be approximately 12.6. And this is in square feet. So the area there will be 12.6 square feet. And that's only for the area of one of the bases. And then part D, they want the lateral surface area of the cylinder. Now the lateral surface area is actually this, 2 pi times the radius times the height, okay? That lateral surface area is the face that's around that particular cylinder. Not these 2 circles on the top. It's this part right here, the face around that cylinder. I'll say 2 times 3.14159. The radius is 2 times the height, which is 3. And if you were to round that off to 1 decimal place, this would be, if you multiply all that out, approximately 37.7 square feet. Okay. And then finally, part C is finding the surface area of that cylinder. All right, so the surface area is going to be 2 pi times the radius squared times the height. No, 2 pi times the radius squared plus 2 pi r times the height. That's the lateral surface area. All right, so in this case here, I'm gonna write down the 2, but that pi r squared, that's up here. That radius, that area for 1 circle is 12.6. But for the 2 circles, we do 2 times 12.6. And then plus 2 pi RH is what we just found in part B. That's a 37.7. So if I do 2 times 12.6 plus 37.7, you'll get, I hope I'm right on this one. I'm going to do this on the calculator 2 times. And this is just approximate. 62.9 square feet. 62.9 square feet. Okay. All right, any questions about finding the surface area of a right prism and for a circular cylinder? Okay. Okay, here we go. All right, here we're going to talk about surface area of a regular pyramid and a right cone. Now, the lateral surface area of a regular pyramid are congruent isosceles or equilateral triangles. Isosceles means that 2 of the sides are equal. Equilateral triangles means all 3 sides are equal in that triangle. Now, here we're going to talk about the slant height of a regular pyramid. That's denoted by lowercase l. That's going to be the line segment from the apex of the pyramid, or what they call the tip of that pyramid, to the midpoint of a side of a regular polygon. That's going to be the height that's on the face of that pyramid. Okay. So here is a representation of the slant height. All right, this triangle in red that you see here, this dotted line, that is the slant height, denoted by lowercase l. That's coming from the tip of the pyramid to a point perpendicular to a side of that pyramid. And then you have your vertical height going from the tip to the center of the base. Okay. So here, that's that slant height that you see here. And then from there, you'll see it a little bit better, because that's the lateral face. That vertical dotted line is your slant height. Okay. And of course, the surface area there would be the area of the base multiplied by the lateral surface area. Okay. And I'm going to skip this slide because they're just deriving this formula here for the surface area of a regular pyramid and for a right cone. For a regular pyramid, its surface area is this. That's just going to be 1/2 the perimeter times the apothem. That's that point from the center of the base to a side perpendicular to it. And then plus 1/2 the perimeter times the slant height. That's the height that's on the face of the pyramid or cone. Well, in this case, the pyramid. And then for a right cone, you have R units for the radius. Slant height would be L units. That's on the face of the cone. The base of that cone has an area of pi r squared. And then that's going to be multiplied by pi times the radius times that slant height. which is L. Okay. So if we look at this example where we have a regular pentagonal pyramid that has a height of 12 centimeters and a base with sides that are 10 centimeters and an apothem of 7 centimeters. Let's say I want to find the slant height of the pyramid, the area of the base, the lateral surface area of the pyramid, and the surface area of that pyramid. Now here we can draw a diagram to visualize those relationships, okay? Now this is what they did. They took a cross-section of this and pulled this out as a triangle. You'll see that this is a right triangle here. The height there is 12. The length of the apothem here is 7. And your L, the slant height, is the height that's on the face of that pyramid. That's what we need to try to find. And the way we do that is use the Pythagorean Theorem, which is what they're going to do on the next slide. So here, the L is considered to be a hypotenuse. So if we want to find the hypotenuse, we take the sum of the squares of those legs, 12 and 7. So 12 squared and 7 squared. I know 12 squared is 144 and 7 squared is 49. So if you add those two together, you'll get 193. And to find out what L is, we're squaring the L, so we need to take the square root of 193. And they left it as the square root of 193 centimeters. And then they found the area of the base, which is of course 1/2 the perimeter times its apothem. And here in this case, the perimeter was 5 times 10, because the base of that pyramid is a pentagon, 5 sides. Each side is 10 units long, so 5 times 10 would be 50, and then times the 7, which is your apothem. And this will give you 175 square centimeters. That would be the base of that pyramid, area of the base. And then the lateral surface area of that pyramid, this is part C, that's 1/2 the perimeter times the slant height. So that's 1/2 the perimeter, 5 times 10, times the square root of 193. This will give you approximately 347.3 square centimeters. What they could have done here, since you'll have to do 1/2 of 5 times 10, that's 50. Half of 50 is 25. And then times the square root of 193 will give you this. And then part D. Here we add the area of the base to the lateral surface area. The area of the base that we found in part B was 175. The lateral surface area that we found in part C is 347.3. So this surface area is approximately 522.3 square centimeters. Okay. All right, now let's look at some problems that I picked out of the textbook. Find the slant height of a cone with a radius of 10 and the height of 18 centimeters. Okay. So we're looking for the slant height, which is lowercase l. So in this case, this is what the right triangle would look like. So this is the slant height that we're looking for here. The radius is down here, that's 10 centimeters. The height goes straight up and down, that's 18. So again, we're going to use that Pythagorean theorem for right triangles. And that's, of course, a squared plus b squared is equal to c squared. This will be a. That's going to be b. Your a is 10 centimeters, so this will be 10. That's going to be squared. Plus b, that's 18 squared. And I'm going to let c be the L that we're looking for. And that'll be L squared. And now we simplify by squaring the 10 and the 18 here. 10 squared is 100. 18 squared is 18 times 18. That's 324. That's going to be equal to L squared. And then if I add 100 to 324, that would be 424. That's equal to L squared. And to find out what L is, the opposite of squaring something would be to take the square root of 424. And if you do the square root of 424, you'll end up getting approximately, to one decimal place, 20.6. So that's the slant height of a cone with a radius of 10 and the height of 18. And that's in centimeters. All right, any questions on any questions about problem number 51? Okay, let's look at problem 5AC, A through C. Now here, the diagram represents a right pentagonal pyramid. A right pentagonal pyramid. And the measurements unit is in centimeters. So in this, we want to find the area of the base, and then find the lateral surface area of that pyramid, and find the surface area of the pyramid. Okay, so let's, I'm gonna draw the figure that's on the slide. Bring this down a bit. Okay. This is 15. Going here is 7.6. And this side is 11. Now there's one thing we need to find. I might need to put this in blue, is the slant height. That's going to be this height that's on the face of the pyramid. So here we need to find out what L is. Okay. So that red line that you see is going to be the height that's on the face of the pyramid. We need to find out what L is first before we do anything. So I'm going to draw a right triangle coming from this. This is 15, that's 7.6. We need to know what L is. So here we need to find out what that is by using the Pythagorean Theorem. Okay. That's going to be 15 squared plus 7.6 squared. That's equal to L squared. And in this case, 15 squared is 225 plus 7.6, and if we square that, that's 57.76. That's equal to L squared. Add that to the 225. This will be 282.76. That would be equal to L squared. And to find out what L is, we take the square root of 282.76. And I'm going to say approximately to one decimal place, 16.8. That's what L is going to be, 16.8. And this is in centimeters. Okay, so now we should be able to find the area of the base. This is part A. Now this right here is the area of the base right here. So this is B is equal to 1/2 the perimeter times the apothem. Now here that apothem is right here. And I drew that wrong. That's the apothem right here. A is 7.6. And of course, there are 5 sides. Each side is 11 centimeters. So the perimeter is 5 times S. So if I do 5 times 11, that'd be 55. So the perimeter of that base is 55. So the area of the base is 1/2 the perimeter of 55 times the apothem of 7.6. So this is going to be approximately equal to approximately, well, it's going to be exactly 209. And this is in square centimeters. So that represents the area of this space down here, 209 centimeters. Then the B part, they want the lateral surface area of the pyramid. All right, so the lateral surface area is this. That's 1/2 the perimeter times the slant height. Okay. So I have 1/2. The perimeter, I found that out to be 55. And we just found out what the slant height was. That's this L, 16.8. this is what I come up with, 462 square centimeters. Okay. That's the lateral surface area. Now, part C is finding the surface area of the pyramid. So here, I take the area of the base, that's the 1/2 P times A, that's just 209, plus the lateral surface area. That's the 1/2 P times L. That's just 462. So if I add 209 and 462, this will be 671. That's square centimeters. So that would be the surface area of that pyramid. Okay. 1/2 PA, that's the area of the base, plus the lateral surface area that we came up with in part B.
So what would be the formula?
Oh, for the surface area?
Yeah.
Okay, here it is. That's 1/2 the perimeter times the apothem plus 1/2 the perimeter times that slant height. This is from part A, and that 1/2 PL, P times L, that came from part B. All you do there is just add those two together. All right, any other questions? Okay. Okay, here we go. Here's another one of these. And it is a pentagonal pyramid. And that that's what we have here. Here we want to find the area of the base, the lateral surface area, and the surface area, the total surface area of that pyramid. Okay. Okay. I'm going to use a different color for this height. And for this. Because we're told the height is 22. And the slant height, let me do this, give you the slant height in green. It's just slant height, 25.2. And the length of the side is 18. All right, so that's what the figure looks like. In this case, I'm going to take out this triangle right here that I have, because we need to know what this apothem is. That's this part down here going from the center of that pentagon to a side on that pentagon. You know, this height is 22. This slant height is 25.2. I don't know what this is. That's the apothem. That's what I'm trying to find. That's A. So here, I have to use the Pythagorean Theorem. A squared plus B squared is equal to C squared. And in this case here, the A is what I'm trying to find. That's A squared. The B is going to be this side right here, 22. And that's squared. Equal to C, that's 25.2. And that's squared. So here, A squared is equal to 22 squared. That's 22 times 22. That's 484. This should be plus. That's equal to 25.2, and that's squared. That'd be 635.04. And then to get A squared by itself, I'm adding 484, so I need to subtract 484 on both sides. So A squared is 635.04 minus 484. This will be 151.04. And to find out what A is, we take the square root of 151.04. And to one decimal place, I'm going to say about 12.3. So that's going to be the length of this apothem right here, 12.3. Okay, and I should have everything I need to know to answer questions A, B, and C. So here I want the area of the base. So the area of the base, that's B, is equal to 1/2 the perimeter times the apothem. But first of all, I need to know what the perimeter here is. It is a pentagon with 5 sides. So the perimeter has to be 5 times S. There's 5 sides in that pentagon. So if I do 5 times the length of the side, which is 18, 5 times 18, that's 90. So here, the base is equal to 1/2 the perimeter, where the perimeter is 90, 1/2 of 90 times the apothem of 12.3. That's what we just found here. Okay, and this is in feet. So the area of the base is 553.5 square feet. Okay, so that's part A. Part B, they want the lateral surface area. And that's, of course, 1/2 the perimeter times the slant height. Okay, that 25.2, this is what L is, 25.2. That's the slant height. So 1/2 the perimeter, we found that out to be 90 times the slant height of 25.2. I got 1,134 square feet. That's the lateral surface area. And then part C is finding the surface area. That's of course 1/2 the perimeter times the aperture plus 1/2 the perimeter times the slant height, which we already found in parts A and B. 1/2 of P times A, that's the 553.5 plus 1/2 P times L, that's what we found in part B, 1134. Add those two together, you'll get approximately 1,687.5 square feet. Okay. Any questions about problem 6A, B, and C? Okay. All right, we'll end with this one. The formula for the surface area of a cylinder is this. Volume is equal to 2 pi r squared plus 2 pi r times the h. Now, they want to know, what does 2 pi r squared represent? Okay. All right, now let's think about this here. The 2 pi r squared, that actually is the area of the two bases of the cylinder. Okay. Let me see if I got enough room to do this. Okay. So if you kind of look at this on this up here, here you got the cylinder where you got two circles on the top, and one on the top and the other one on the bottom. Those are the bases. Those two represent the area of those two bases in the cylinder, because the area of a circle is pi r squared. And this is also pi r squared, so that's why you have 2 pi r squared. Okay. And part B, okay, here's part B. What does 2 pi RH represent? That's of course a lateral surface area. Okay, so if you look at this part right here, it's hard to see, but when you flatten this out, that's the lateral surface area of that cylinder. Okay. All right, any questions about problem number 8? Okay. All right, I will end this right here. I do have one more problem dealing with surface area. It is going to be of a cone. I'll do that on Wednesday, and then we'll end section 11.4 with surface area and volume of a sphere. And then we'll go into chapter 13 that deals with lines. Okay. All right. Do make sure your signature is on the sign-in sheet, and also for those who are in Zoom, make sure that you place your name in the chat box. And I will talk with you on Wednesday. See you on Wednesday.
Have a good day, Professor.
Thank
You
you.
too.
Hey, Mr. Wilkinson,
Yes, ma'am.
is there any way that I could speak with you about making up the work that I missed? This is Sylvia Sam. I emailed you, but I never got an email back.
Okay, I have to check my email. I've been busy all weekend, so,
Well, was about 2 weeks ago when I emailed you.
okay. We can talk about that.
Do you want
And
me to just?
I'll tell you what, I will email you. We can,
Yes, sir.
yeah.
Okay.
Thank you.